let's go over section 1.4 and do some homework questions. Question number 1, let's simplify x squared equals negative 289. For this question, I'm going to start by taking the square root of both sides. Now when you take the square root of both sides, please put the plus or minus in front of the constant term. On the left, it becomes x. And on the right, I can take out the square root of negative 1, which is just I. Then we have the square root of 289 inside. Now, of course, we want to break down 289. We want to see if it's factorable. And I can see here that 289 is 17 times 17. So we can also use our calculators and figure out what the square root of 289 is. That's 17. And so our solution is x equals plus or minus 17r. Question 2, let's solve by factoring. I want to check to see if there's a GCF first. I don't see one, so we'll move on to the next process, and that's going to be the AC method. Now let's multiply 3 times 16. 3 times 16 gives me 48, and then we'll put the 19 on the bottom. So what two numbers multiply to get 48 and add up to 19? Well, I think that's going to be 3 and 16. Because we use 3 times 16 to make 48, and 3 plus 16 does give us 19. So these are the two numbers we need to use for our AC method. We'll rewrite the middle as 3m plus 16m plus 16 equals 0. We'll do factor by grouping now. The first two terms contain a 3m in common. That leaves us m plus 1. The second two terms have 16 in common. That leaves us an m plus 1. Since these are both the same factors, we can pull that out to the front, m plus 1 times 3m plus 16 equals 0. Of course, since they both multiply to equal 0, I can set both of them equal to 0 and solve for m. The first one, we can subtract 1 to both sides, m equals negative 1. For this one, we'll subtract 16 to both sides first. 3m equals negative 16, and I could divide both sides by 3. m equals negative 16 thirds. We have two solutions, negative 1 and negative 16 over 3. You could always plug that back into the original equation to check your work. Question 3, find all the solutions by factoring. Before we start, always set it equal to 0. So we now have the equation equal to 0. And again, there's no GCF, so let's use the AC method. We have negative 30 on top, negative 13 on the bottom. The two numbers that work are negative 15 and positive 2. Negative 15 times 2 does give me negative 30. Negative 15 plus 2 does give me negative 13. Again, we're going to split the middle because of that leading coefficient. And the middle is split as negative 15w plus 2w. We'll do factor by grouping. Let's take out a 3w to the front. We have w minus 5. And here I'll take out a 2. We have w minus 5 again. We can factor out w minus 5. And that leaves us 3w plus 2 equals 0. I could set w minus 5 equal to 0, or 3w plus 2 equals 0, and we can add 5 to both sides here. W equals 5 is one solution. For the other one, we'll subtract 2 first. Divide both sides by 3. And that means W equals negative 2/3. Question 4. Let's solve by the zero factor property. I know this is the difference of squares, a minus b times a plus b. So I can rewrite this as x minus 7 times x plus 7, and that's equal to 0. Since each of these multiply to give me 0, I can set each of the factors equal to 0 separately. And so we have x equals 7, or x equals negative 7. In question 5, I'm going to again try to factor this problem. Let's check for a GCF. Unfortunately, we don't see a GCF, so we'll use the AC method again. 4 times 49. That gives me 196, and then on the bottom 28. So the hardest part is to find these two numbers that work. And I have found the numbers. They're 14 and 14. So we can split the middle now, 49x squared, with the middle split as 14x plus 14x plus 4 equals to 0. Now we could do factor by grouping. I can take out a 7x from these two. That leaves me 7x plus 2. I could take out a 2 from 14x and 4. That leaves me 7x plus 2. Again, these are the same factors, so I know we're doing it right. Let's take out 7x plus 2, and that leaves us 7x plus 2 equals to 0. This implies that 7x plus 2 equals 0, or 7x plus 2 equals 0. Well, since they're both the same equation, I only need to solve it once. So let's solve it one time. Subtract 2 to both sides. And we can see that x is equal to negative 2 over 7. Now, since we have two solutions that are the same, we have a multiplicity of 2. So negative 2 over 7 is a solution twice. We say that it has a multiplicity of 2. Question 6, let's solve with the square root property. That means I can take the square root of both sides. Don't forget the plus or minus, and that's going to cancel out that radical. Square root of 21, I can't simplify that. That's 3 times 7. We'll leave that alone. But I can add the 2 to both sides now. Don't forget that you put the 2 in front of the plus or minus. Don't put it behind or with the 21, put it in front of the plus or minus. And now we could divide both sides by 2. Here is our result. We have 2 plus or minus root 21 over 2. Now please don't feel tempted to simplify the 2 and the 2. You can't do it because of that plus or minus. So don't simplify the 2's. Don't reduce them. In question number 7, same process. Let's take the square root of both sides and we'll solve for z. Don't forget that plus or minus when you take the square root of both sides. I have z plus 7 equals plus or minus. I can take out the I, and 14 is 2 times 7, though there's no pairs, so we can't simplify the square root of 14. We can solve for the z. Let's subtract the 7 to both sides. And z equals -7 plus or minus I root 14. That's a good solution. We're done with number 7. This says we have to solve by completing the square. So I need to add b divided by 2 squared to both sides. Before we start, let's move that 9 to the other side. We have x squared plus 8x plus, I need to add something here, and I need to also add something here. Now what is that something? Well, we need to take the b, which is 8. 8 divided by 2 squared gives me 4 squared, or 16. So I need to add 16 on the left, and in order for this to be true, I need to add it on the right. This means I can factor the left side as x plus 4 squared. Remember, the shortcut is to take that b, cut it in half, and put it down here. That gives me that 4. So this is x plus 4 squared equals 25. Now we can take the square root of both sides. Don't forget the plus or minus. And this gives us x plus 4 equals plus or minus 5. Now leave that plus or minus 5 alone. Subtract the 4 first. Let's subtract the 4 to both sides. And again, you want to put that negative 4 in front of the plus or minus. Do not subtract it from the 5. This gives me -4 plus or minus 5. Some people stop here thinking this is a good answer. No, it's not a good answer. You could simplify further. Let's do -4 minus 5. That's -9. Or I can do -4 plus 5. That gives me a +1. So we have two answers. Do the subtraction first. You get the -9. Do the addition. You get the +1. If you're not sure this is a good solution, go back, plug it into your original polynomial, and see if it works. So that's how we complete the square. We have to add that b over 2 squared to both sides. In question 9, it says solve by completing the square. Now for this question, it's going to be very difficult by completing the square. I do not recommend using complete the square. If you see something like this on the exam, and it doesn't tell you that you have to use completing the square, use something else like the quadratic formula or factoring. But since this is in the directions, I have to do it, so let's try completing the square. I want to rewrite my expression so it looks like x squared plus bx equals c. In order to do that, we'll subtract. In order to do that, we'll add the 3 to both sides first. I have 4x squared minus x equals 3. Let's divide everything by 4 because I cannot complete the square unless this leading number is equal to 1. I want the leading coefficient to be equal to 1. So the leading coefficient has to be equal to 1. So make sure that leading number is equal to 1 before you complete the square. This gives me x squared minus 1/4 x equals 3/4. Now we're getting close. We're getting close because we have x squared plus a constant. We're getting close because it looks more like x squared plus bx equals c. So let's leave ourselves some space and let's figure out what we need to add in these boxes. I have negative 1/4. I have to divide that by 2 and then square it. Remember, the formula for completing the square is b over 2 squared. So we'll take the b, which is negative 1/4, divided by 2, and then we'll square it. Negative 1/4 divided by 2 is negative 1/8. Remember, I keep the first fraction the same and then take the reciprocal of the second term. It gives us negative 1/8. If you square it, that actually becomes 1 over 64. So our number is 1 over 64. That's what we need to add to both sides. Now here is where people get stuck. How are you supposed to factor this? Well, remember the shortcut. We take negative 1/4 and divide it by 2. That's negative 1/8. And we square it. This is x minus 1/8 squared. I just factor the left side very quickly using our shortcut. We take the b, cut it in half. It puts it down here. We have x minus 1 over 8 squared. Now, I need a common denominator, so let's get that 4 to become a 64. That means I need to multiply the top and bottom by 16. That would make the bottom 64, and the top is 3 times 16. 3 times 16 is 48. And now when I add these two fractions together, I have 49 over 64. Again, 48 plus 1 is 49, and the denominator is still 64. Let's take the square root of both sides. Don't forget that plus or minus. Now that gives me x minus 1 over 8 equals plus or minus the square root of 49 over the square root of 64. I use the quotient rule to simplify the right side. I have x minus 1 over 8 equals plus or minus 7 over plus or minus 8. The square root of 49 is 7. The square root of 64 is 8. Let's add 1/8 to both sides. Let's put that in front of the plus or minus. I have x equals 1/8 plus or minus 7/8, and we can simplify it even further. We have x equals 1 plus or minus 7 over 8, and now we could write two separate equations. We have 1 minus 7, which is negative 6 over 8, or that simplifies to negative 3/4. And for the other one, we could do 1 plus 7. That simplifies to 8 over 8, or just 1. We have two solutions in this problem, negative 3/4 and 1. Question 10, I want to solve the equation using the quadratic formula. Let's recall the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So please memorize that quadratic formula. You're going to use it a lot. We have a is equal to 1, b equals 3, c equals negative 6. So let's use that quadratic formula. X is equal to, we have negative 3 plus or minus the square root. 3 squared minus 4 times 1 times negative 6 over 2 times 1. I have negative 3 plus or minus the square root. This is a 9 plus this is 24. And we have x equals negative 3 plus or minus 9 plus 24. That's going to give me 33 over 2. So it's negative 3 plus or minus the square root of 33 over 2. Question 11. Again, we're going to use the quadratic formula. x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now the problem here is you have to set it equal to 0 before you can use the quadratic formula. So I'm going to add 4x squared to both sides. I get 0 equals 4x squared minus 11x plus 15. I like to keep that leading coefficient positive, so I chose to add 4x squared to both sides rather than moving the 11 and the 15. It just made more sense to keep the a to be a positive number. A is now 4, b equals negative 11, and c equals 15. Let's use the quadratic formula. X equals negative 11 plus or minus the square root of negative 11 squared minus 4 times 15 divided by 2 times 4. Now let's simplify this with a calculator. We have negative 11 is positive 11 plus or minus. I can use the inside with the calculator, and that gives me negative 119 over 8. Let's simplify 119. I know I can take out the I to the front, and I have 119 on the inside. Now the problem is 119. 119 can be broken down as 7 times 17. Now since there's no pairs, that's it. We can't simplify it further. We're done. X equals 11 plus or minus I root 119 over 8. Question 12. Again, we're going to use the quadratic formula. But before we do the quadratic formula, let's look for the LCD. The LCD is 21. Let's multiply that LCD to everything. So 21 times each of the terms. I have 21 times 1 over 7x squared. 21 times 1 over 21x. Negative 21 times 1. And 21 times 0. Again, we're multiplying 4 terms by 21. That simplifies as 3x squared plus x minus 21 equals 0. Now the reason we did this is so we don't have to use the quadratic formula with fractions. So much easier now. A is 3, b is 1, and c is negative 21. Let's plug it into the formula. X equals negative 1 plus or minus the square root of 1 squared minus 4 times 3 times negative 21 divided by 2 times 3. X is equal to negative 1 plus or minus. Now I'm going to simplify the inside with a calculator. I get 253 on the inside, and on the bottom we have a 6. Let's try to simplify 253. That is 11 times 23, so there's no pairs. That is the simplest we can make it. We have negative 1 plus or minus the square root of 253 over 6. Question 13. Unfortunately, we can't use the quadratic formula yet. We got to FOIL this out. So let's FOIL it out first. X squared negative 4x, negative 2x, and plus 8 equals negative 1. We'll collect the middle terms first. We have x squared minus 6x plus 8 equals negative 1. Then I can add 1 to both sides. I have x squared minus 6x plus 9 equals 0. And now we can use the quadratic formula. A equals 1, B equals negative 6, and C equals 9. Let's plug it into the formula. Negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 9 all over 2 times 1. Again, practice plugging in into the formula. Remember the quadratic formula. You're going to use it a lot. So we have a 6 plus or minus. Now I could type this in a calculator. And this actually gives me a 0. The square root of 0 is just 0. So my answer is x equals 6 over 2 or x equals 3. So we only have one solution here, and that's x equals 3. Now what does this tell me? It tells me that I could have factored the original equation and have been done much quicker. So just remember that you could have done this problem by factoring and you would have been done a lot quicker, but we chose the quadratic formula because that's what the direction told us to do. So look at this right here. We have x squared minus 6x plus 9. I could have used the diamond method and I would have got negative 3 and negative 3. It factors as x minus 3 times x minus 3, and we would have been done in 30 seconds. Now, I always try to factor first. If that fails, do something else.